You sit the Cambridge IGCSE Physics 0625 exam. You memorize every single formula. But you still bleed marks on paper 4 or 6 and wonder where it all went wrong. Today, we are cracking the examiner's secret rubric for measurements, density, and uncertainty. By the end of this explainer, you're going to know exactly how to build bulletproof answers that literally force the examiner to give you full marks. Let's get right into it. Picture this. You're in the exam hall. You've perfectly measured mass, perfectly measured volume. You type it into your calculator, and you just write down exactly what the screen spits out, right? Density equals 8.33333333. I mean, it feels like a total win. The math is functionally flawless. You probably think you just secured all the points for that calculation. But here is the brutal reality. Why does this quote-unquote perfectly calculated answer score exactly 0 marks on a Cambridge exam? Well, it happens because ordinary revision totally fails when you don't actually speak the examiner's language. They are just testing if you know how to divide two numbers. They are actively testing your ability to communicate scientific data accurately. This answer, it has absolutely no units. Plus, the student completely ignored significant figures, effectively claiming an impossible level of precision. If you don't understand the mark scheme, you are going to lose these easy points every single time. Okay, let's dive into this and ground ourselves in exactly where we are in the syllabus. We're looking right here at Section 1, Measurements and Units. More specifically, we're zooming in on chapters 1.3 through 1.6, covering measuring length and time, volume, density, and the practical methods used to actually find them. This right here is the absolute bedrock of your physics knowledge. If your foundational measurement skills are even slightly shaky, your practical investigations and data analysis later in the paper, they're going to completely fall apart. So to win this game, you've got to know exactly what traps the examiner has set for you. Let's look at the most common measurement pitfalls that literally destroy grade boundaries. Missing units is by far the biggest offender. Guys, a number without a unit is just a number. It's not a physical quantity. Then we've got rounding too early in your multi-step calculations. That creates compound errors that throw your final answer way outside the acceptable range. We also see super vague explanations, like just writing measure carefully, instead of saying read at eye level to avoid parallax error. And definitely watch out for graph axis errors, giving weak practical improvements, and drawn conclusions that your data just doesn't support. Section 1. The Core Measurement Toolkit. To dodge all those traps, we have to completely master our apparatus. Every practical investigation requires you to select the exact right tool for the job. Look, choosing a standard ruler when you actually need a micrometer screw gauge is a surefire way to instantly lose method marks. Let's speed run through this table really quick. These are the exact tools required by the Cambridge rubric. For length, we're working in millimeters, centimeters, or meters. You have to know when a standard ruler is perfectly fine and when you absolutely need the precision of a micrometer, like say when measuring the diameter of a wire. Time, standard in seconds, requiring a stopwatch. Volume uses cubic centimeters or milliliters with a measuring cylinder. In density, measured in grams per cubic centimeter or kilograms per cubic meter, fundamentally requires two tools, a balance to find the mass and a measuring cylinder or a displacement can to find the volume. Burn this table into your memory. Now, knowing these tools is really just step 1. In a moment, I'll show you the exact examiner clue that changes your answer completely. But first, you need the framework that makes that clue super obvious. Because when you're staring down a blank set of lines on a massive 6-mark question, panic is your worst enemy. Structure is your best friend. Section 2. The Top Band Answer Framework. This framework right here is your definitive strategy for structuring exam answers so that you systematically fulfill every single command word and leave absolutely 0 marks on the table. The crucial point is the simple 4-step sequence. Step 1, concept. What is the fundamental physics principle being tested? Just state it clearly. Step 2, evidence or data. Pull the specific numbers or observations directly from the source page, graph, or experiment they gave you in the question. Step 3, scientific reasoning. This is where you connect your data to your concept, show the calculation or logical link. And finally, step 4, examiner wording. Wrap it all up using the precise terminology the syllabus demands. Don't just say, it gets bigger, write the volume increases. And this brilliantly illustrates the difference in action. Over on the left, we've got our flawed student answer. I found the volume and mass and divided them to get density. I mean, it's vague, it completely lacks evidence, and it doesn't even give a final value. Now look at the top band answer on the right. Using the equation, density equals mass divided by volume. Boom, that's the concept. I substituted the measured mass, 45 grams, and volume, 15 cubic centimeters. There's the evidence. To calculate a density of 3.0, that's our scientific reasoning. Grams per cubic centimeter, ensuring units and correct significant figures. Guys, that right there is peak examiner wording. That is exactly how you secure full marks.
Section 3, the speed run challenge.
All right, now it's time to put your own skills to the test and escalate the stakes a bit. I'm going to show you a piece of data from a practical experiment, and I want you to try to instantly spot the missing links that would absolutely trigger a penalty from the Cambridge examiner. A student writes this in their practical evaluation. The time taken for the pendulum swing was 12, so the experiment is reliable. Okay, pause for a second. Try to predict exactly what is wrong with this statement. Think about missing variables, missing units, and the actual strict definition of reliability in a physics experiment. What did they completely fail to do?
Let's pull up the examiner's correction and see how this all connects. First off, the number 12 means absolutely nothing without a unit. It must be 12 seconds. Second, timing just a single swing is wildly inaccurate because of human reaction time. Notice they didn't state how many swings were timed. Normally, you should time 10 or 20 oscillations and then divide. Third, they confidently claimed the experiment is reliable but completely failed to mention taking any repeat readings. You literally cannot prove reliability without repeating the experiment, identifying anomalous results, and calculating a mean average. That student just threw away 3 marks in a single, tiny sentence.
So to make sure you never, ever make these mistakes, I want you to mentally run through this final answer checklist every single time you finish a calculation or practical question. Ask yourself, are the units included? Are my significant figures correct, actually matching the least precise piece of data I was given? If I drew a graph, is the scale logical, and does it take up at least half the page? Have I minimized uncertainties, like actively avoiding parallax error? And maybe the most important one, is the final answer actually reasonable? Look, if you calculate the density of a block of wood and it ends up being heavier than a black hole, you've definitely flipped your division. Always do a quick common sense check.
If you master this toolkit, you are going to confidently secure the marks on all those standard measurement and calculation questions. But what happens when your practical data contains a massive anomaly that completely ruins your line of best fit and entirely throws off your gradient calculation? Fixing that requires a completely different level of mark scheme thinking. To conquer that and really master the hardest practical skills on the paper, you need to stick around. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. And join us for the next explainer where we're going to speed run the absolute most difficult past paper graph skills. You definitely cannot afford to miss it. See you there.